Welcome you all students for the second lecture video. Uh, for today, I am going to take the topic in the unit 1 itself from the analog electronic circuits, that is the thermal stability. We can also call it as thermal runaway. It is an important topic. Maybe they will ask in a 2 mark or 4 marks because it is a small topic, but we have to make this important even for the higher level competitive examinations. They will be asking these topics again and again. So thermal stability, thermally you know about that. It is because of the heat which will be dissipating right here. So we go over to here, thermal stability or thermal runaway. So we mostly consider for the transistors or whatever maybe we are using here for amplification purpose only. Even though it's small devices that cannot able to withstand so much of heat, and even though we can able to say the main cause of this thermal runaway because of the current flowing through across the devices, right? So if we take a common emitter configuration, CE configuration, for any amplifier, the most preferred method is common emitter, right? So the culture current output will be beta into IB, beta is an amplification factor, IB is a base current because of the base current, and plus 1 plus beta into the ICO, the leakage collector current, right? Yeah, we can able to say that. The leakage current is also main important thing. This is the flow of minority charge carriers also we can able to say. If we take a whatever the transistor type we have taken, there will be definitely current due to majority carriers are also due to minority carriers. So here the ICO considers the flow of minority charge carriers. If the temperature increases, what happens? Definitely the minority carriers will be increasing also. So the concentration of minority charge carriers also increasing. That increases your leakage collector current. That is denoted as I subscript of CO. So if collector leakage current increases, that also able to add with your collector current. So the overall will be current collector current will be increasing here. So we already know that if you see the statement, will be considered here when temperature is increasing, definitely my minor charge carriers as well as the leakage current will also be increasing. So definitely my collector current increasing. So I can able to directly take the statement as temperature increases, that is directly proportional to the increase in the collector current. So temperature is directly proportional to the collector current right here. So if you go for a general definition, that is defines that every 10 degrees Celsius heat will be increasing, that doubles your leakage current, collector current here. So that is statement given here. For every 10 degrees Celsius of temperature increases, that will doubles the leakage collector current. So what happens if you say that the flow of collector current increases? What happens? This also makes the device to be in producing heat. So the production of heat also increases your temperature again. So then collector current also increases again. So by the statement given before here, so what happens? So the flow of again the current increases because of the leakage current. It also increases your temperature. So if temperature increases, then definitely collector current is increasing. So what happens? If you see that it's look like a cycle. So when normal temperature increases, that will increase your collector leakage current, as well as because of this increase, the collector current is also increasing. So the flow of current again and again increasing means the heat is also dissipating more. Then again, because of the heat, temperature is also again decreasing. So what happened? If this life cycle, sorry, if this cycle is been going on again and again, definitely within maybe a few seconds also, because of the small transistor that is having a withstand capability is very less, it will be able to burn the transistors. It is said to be mean like thermal runaway. You can see the diagram here. So see here, when uh, the resistance, we can start from the here. When the power dissipation increases, what happens? It will increase your temperature of the collector base junction. So that's why I'm telling it, right? So will increase the collector base junction. Because of these, we'll be able to make increase the resistance of the device will be decreasing. So may the flow of current is more than the normal. Okay. So what happened? The flow of current is increasing. Definitely, the collector current is also increasing. The collector current increases. Again, the power dissipation will be more. So this is the thermal runaway process. So due to this cycle, what happens? You can able to have a thermal runaway. You can see this image, right? So it will melt your transistors, whatever you are using, because they have the only less withstand capability. right. So this was I am showing here to understand very easily. Is it right? So the self-destruction of unstable transistor is shown as thermal runaway. So the capability of transistors, we have to know that that is meant to be a thermal stability. Okay, so how can you able to make this not to be a have a thermal runaway, or we can able to make a mitigation of thermal runaway? What we can do to reduce this type of thing here? Uh, Nothing one, we already know that because of the self biasing or voltage divider biasing, the negative feedback is invented. So what happens? Negative feedback will be get by the ratios, denominator, that's the ratio of numerator and denominator. So the numerator value can be controlled by the denominator value. Is it right? So already know that because of the negative feedback, what you have here is when collector current is increasing, what happened? The base current will be decreasing because of the ratios. So this base current decreases, what happened? Again, it will able to eliminate, or it can able to avoid more current to be flow through the collector region. So this will compensate, or this will not compensate, actually this will able to make you value reducing in the collector current. So due to the emitter resistance also we are considered here, right, in self bias voltage divider bias. So because of this, what happened? The feedback can able to control your main collector current. This is one of the possibility or one of the mitigation when thermal runaway is being taken there. And second type of mitigation we are using is heat sinks. If you see many type of transistors in physical components in here, there will be like a if normal BJT transistors are fitted that like a BJT or maybe there will be a cap like that in the image of your here. I'll try to add that images also. So what happens? That may be able to uh, pass that heat temperature what we are dissipating here. The heat can be uh, have with the help of an air gap, so the heat can be able to somewhat dissipate, because if it is open like in a space or something, definitely the air will be able to reduce your heat. Okay, even if you go for a real-time example, if your car is the engine has been heated or something has been heated, what you will do here, you will open to the space and be idle for some time or some minutes, so it can able to cool that heat dissipation by making a air passing, right? The same thing here also we are using a heat sinks in many type of devices. Even if you see in, nowadays in real time in many applications like TV or something, definitely there will be a transistor will be or FET. We are able to use it in the devices, real-time devices. FET means maybe a MOSFET or water, maybe C MOSFET or something. Okay, definitely there will be a heat sink that will be able to reduce your heat dissipation. So if heat is been reduces as much as possible, the temperature will also be not able to make increase. It will be stable. Okay, whether not to be increased temperature, but we can able to make it stable. So the temperature is stable. So what happened? The leakage current is also maintain the stable stabilization. So the collector current is also flow like a constant, right? So whatever the thing here. So it will able to break your cycle of your uh, thermal runaway. So that may reduce your thermal runaway possibilities, and actually it maintain a thermal stability. So this is the concept of thermal runaway or thermal stability. So it is an important topic. Uh, so try to study this also. Maybe ask in many examinations and many 2 marks in the question and answers. If you have any doubts regarding this topic or something, you can ask me through classes also, or you can able to use any social media app. And thank you for listening. Thank you once again. Thank you.